Okay, so in today's workshop, this is the last workshop in like this series, so the last microecon workshop, and today I'll be going over choice and utility maximization, and I'm also going to do a whole midterm, like past midterm, because I feel like that's what a lot of people wanted. So like the actual slides aren't that much, and then I'll just do like 2 questions from a past midterm. So this is just like a little bit of background. So a decision maker chooses their most preferred alternative from those available and feasible for them. This is just like stuff that I've talked about before, but I just want to bring up again. So a budget set is a set of feasible alternatives it's a set of feasible alternatives, and the best affordable bundle is the best bundle from for the consumer from the set of affordable bundles to them. So this is how we set up basically a problem. I'm just going to keep admitting people because I think a lot of people are joining now.
Go vertical like this.
Okay, so this is how you set up the consumer's choice problem. So for example, if the consumer only consumes 2 goods, good 1 and good 2, this is how you represent the bundle. So you go X is equal to open bracket X1, comma, X2, close bracket. P1 is the price of good 1, P2 is the price of good 2, and M is basically income. So we've done this all before. I just want to bring it up again because I'm going to do the past midterm. So the budget set is basically represented by P1 times X1 plus P2 times X2 is equal to or smaller than M, which is the income. So in order to calculate the best affordable bundle, you have to like solve it. So X star is usually what we call the best affordable bundle. So the star is to represent like what the consumer wants the most or that fits their criteria in the best way. So if P1, P2, and M are parameters, X1 star, open bracket P1, comma, P2, comma, M, and X2 star, P1, comma, P2, comma, M are Marshallian demand functions. So this is really important because this always comes up in a midterm. They'll ask you how to like to solve for the demand function. So we'll go through that. So this again, I'm just kind of like doing some notation is that UX is a utility function. The text got like a little messed up in the PowerPoint. But yeah, this is all just like basic stuff. And this is called a constraint maximization problem or a constraint choice problem. So that's what we're going to be solving for today. So again, I just want to show you some graphs about what it's supposed to look like. So this is the standard case of a constraint choice problem, and you see the indifference curve, you see the budget line, and in the middle where the budget line and the indifference curve meet is the best affordable bundle, at which the marginal rate of substitution is the slope, which is minus P1 over P2. This is it for perfect complements. So like we've seen before, it's kind of like an L-shaped. I've just annotated some of the, like the best affordable bundle, the budget line, and the indifference curves, just if you guys want to go through it later. And this is it for perfect substitutes. We saw that it was just like a straight, like downward sloping line. And these are just some notes that I want to talk about before I move on to actually solving some problems. So consumers maximize their utility subject to their budget constraint. The highest indifference curve attainable given the budget is the consumer's optimal bundle. And then there's 2 solutions that we need to talk about. So the interior solution, when the optimal bundle occurs at a point of tangency between the indifference curve and the budget line, this is called an interior solution. So for example, this point, the blue circle would be an interior solution because that's when they're intersecting. A corner solution is if the relative price of one good is too high and the preferences are quasi-linear, the indifference curve will not be tangent to the budget line and the consumer's optimal bundle occurs at a corner solution. So I don't think I have anything for a corner solution here, but it usually does come up. So I'm just going to stop recording for a sec. Okay, so for those of you who just joined us, I just went over some like basic things that we've gone over in the past workshops. So I'll just put up these slides. It's nothing like super new, but now we'll go through a past midterm. So this is the first question. I'm just going to give you guys like 1-2 minutes to read through the question, and then can somebody just say yes when they're ready to kind of go through it. Are you guys ready to go through it? Do you need some more time?
For me, I think I'm ready because
Okay.
I just yeah.
Okay, perfect. So this is a pretty like good example of what you could get on your midterm. So I'll go through this, and then the next question is more about like consumer choice, like utility. So we'll just go through this. So for the first part, so suppose Anne got 70 on her first exam, so then x1 is equal to 70. X2 and x3 are her scores on the second and third exam respectively. And in this case, they're asking us to consider that x2, which is what her score on her second exam, is 60, and x3, her score on her third exam, are 80. So this is how I would go about showing, like, doing something like this. So what I like to do is just write a few notes from the question itself. So we know that Anne does 3 exams, and each exam is x1, x2, x3 respectively. Each exam is out of 100. And then the professor drops the lowest score, and her final grade is an average of the highest 2 scores. And the higher that the grade is, the higher Anne's utility is. So basically what we're trying to do here is make sure that she gets the highest grade she can from the 3 exams that she's sat. So we say that the utility of x1, x2, and x3 is her final grade. And in order to calculate that with the information that they've given us, what we do is kind of set about a problem, put about like possible like solutions. So for example, if x3, which is the score of her third exam, is lower than the score of her first exam, and it's lower than the score of her second exam, we just consider her first exam and her second exam scores. Then the utility that she gains, or her final score that she gains after these set of exams, would be half of x1 plus x2. So this is basically like, it's a pretty simple like equation. It's just an average of her highest 2 grades. And here I've written the same for if x2 or her second exam score is the lowest, and here if x1, her first exam score, is the lowest out of the 3. So in the first part of the question, they tell us that the first exam score is 70. And then they tell us that the second exam score is 60 and the third is 80. So in order to kind of create the problem, or like how we're going to solve it, I just wrote it out like this. You can write it out however you want, but I feel like it's just easier to do everything step by step, because first they gave us 70, then they gave us 60 and 80. So I just wrote it out like this, and now we can see that 60, which is our second exam score, is the lowest out of the 3. So that's the one we're going to drop. We're not going to consider 60 anymore. So in order to solve this, we're going to do half of x1 plus x3, which is half of 70 plus 80, which is 75. So this is the first part of the first part of the question solved. Now we know that the utility that she gains, or her final exam score, is 75. So she's gotten a 75% overall because we dropped her second exam score. And here in the question, they asked us to draw her indifference curve. In order to do that, this is what we are going to do. With the information that we've gotten, we need to kind of map out the different things. So I'm just going to walk you through how I did this. So the maximum that she could get on an exam is 100. But we know that that's not what she's gotten. It's just so that we can see how it would look if she got 100 on all of her exams. So that's, can you guys see my cursor when I move it like across?
Yeah.
Yeah,
Yeah.
okay. So this is 100. This here, so I've done the same for some of the other things because they told us that 80 is one of her exam scores, 70 is one of them, and 60 is one of them. But the actual indifference curve is only the red part. I think it's a little hard to see, but so I'm just going to zoom in. But this is her actual indifference curve. And we know that this is what it is. And there's a little kind of like drop here because we know that the utility is 75. So technically, all you need to draw for this, for the indifference curve question, is the red part, not the rest of it. I've just drawn the rest of it so that you guys can get an idea of what it's supposed to look like. So this is all you're supposed to do for the first part of the question, and it's a pretty good question, pretty straightforward. So yeah, does anyone have any questions about this?
Why is it that the curve goes through through 80?
The curve goes through 80 because that's the highest of the scores. So in order for us to kind of show like 75, do you see this, like the little line?
Yeah.
The little red line. So that demonstrates like the 75. So the highest technically she could have gotten from this set of results, like 70, 60, 80 is 80, but she didn't get that because she didn't get an 80 on the first exam as well. Do you understand what I'm saying? I feel like it's a little bit confusing the way that I'm saying it, but you're supposed to do the highest of the 3 marks that she has gotten.
Yeah, oh yeah, I get it now.
Yeah, okay. So are there any other questions for this part? This is a pretty good like exam overall. Like when I did it last year, when I was practicing, I enjoyed it. And the midterm is pretty similar, so. Okay, so the second part of this question asks, are Anne's preferences on the exam scores strictly monotonic? Are they convex? And they want us to explain. So this is something that I talked about, I think last time. I just kind of defined what monotonicity is and what convexity is. And I told you guys that we would do like an example later. So this is where we're doing it now. So again, here, obviously you don't have to write the definition in your exam. I just wrote it so that we can like go through it together, just like as a reminder. So strict monotonicity means that if bundle X has more goods than bundle Y, then bundle X is preferred. So in order to check if Anne's preferences are monotonic, we're going to consider 2 bundles. This doesn't, like, you don't have to consider the same bundles as the one that they gave us in the first part of the question, but I just used that because I feel like it was easier to carry on with. So bundle 1 says that on her first exam score, she got 70 marks. On her second one, she got 60. And on her third one, she got 80. And then the second bundle says that on her first exam, she got 70. On her second one, she also got 70. And on her third one, she got 80. So the only difference between bundle 1 and bundle 2 is that on bundle in exam 2, she got 10 marks higher than she did on the first bundle. So what I wanted to do is just derive the utility for both the bundles. So for bundle 1, we already know that it's 75, but I wrote it out again just so that you can see how. And for bundle 2, it's also 75 because it's the same 2 scores that we're using. We're using 70 and 80. And now here's the explanation. You need to kind of, when they say explain, you need to write out an explanation and not just kind of do the math. So because bundle 2 has more goods. As we can see, it has 10, like the way that we're looking at it is that her exam scores are her goods. So she has 10 more goods technically in bundle 2, more than bundle 1, but it's not strictly preferred because the same utility is achieved. She gets the same utility if she gets 60 on the second exam in bundle 1, or if she gets 70 on the second exam in bundle 2, because she's already gotten a grade of 70 before. So this is why Anne's preferences are not strictly monotonic, because even though she has more goods, or in this case, a higher exam score, they're not, like, it doesn't give her more utility. Does this make sense to everyone?
Yeah.
Okay, sounds good. So the second part asks us to see if her preferences are convex. So what convexity means is that an agent, in this case Anne, would prefer averages over extremes. So last year when I looked at this question, I was a little bit confused about what kind of average they were talking about, but now like it's pretty straightforward. So I'm just going to explain to you how I did it, like what my thinking was. So in order to check if Anne's preferences are convex, again, we are considering two bundles. In this case, the utility is also the same, but the way that the exam scores are kind of like distributed are a little bit different. So in bundle 1, her first exam score is 70, x2 is 80, and x3 is 0. But in bundle 2, x1 is 70, x2 is 0, and x3 is 80. So as you can see, you get the same average no matter what you do because the 0 gets dropped in both cases. Now, if we were to consider the average, the utility changes because you do half of 70, 80, and 0, and then half of 70, 0, and 80. This turns into half of 70, which remains the same. 40 in this case, because 0 plus 80 is equal to 80 divided by 2, which means it's 40. And that's the same case for the third exam. So here you see that half of 70 plus 40 is equal to 55. Now we know that 55 is less than 75. So if they average out the scores in this way, instead of looking at the extremes, she would derive, less utility because in this case, she's getting a lower score. So now the average isn't preferred. And thus, Anne's preferences are not convex. So like I said, pretty straightforward, but if anyone has any questions, you can let me know now. Okay, so this was the first question. This was basically 50% of the exam already done. So as you can see, like it's a pretty good way how the exam is set out, or it was in the past, and hopefully it'll be the same this year. And now we'll go on to question B, which is the second question. So again, I'm just going to give you guys like 2 minutes to go through the question and then just let me know when you're done. Is everyone good? Do you need some more time or is this okay? Okay.
I'm good.
Yeah, okay, yeah. So I'm just gonna move on. I do write a little bit about the question when I'm solving it anyway, so you guys can see it then if you needed some more time. So here again, as you can see, I've written kind of like just little points in order for me to like remember the question so I don't have to go back. What you guys can also do is just highlight or underline the question. I don't know why I don't do that, but I just prefer it this way. So Bob is a consumer. He consumes two goods, beer and pizza. So X1 in this case is pizza and X2 in this case is beer. His utility function is actually like a Cobb-Douglas utility function, I'm pretty sure. And so his utility for X1 and X2, or pizza and beer, is equal to 20 ln X1 plus X2. So usually, like as we've seen in the past, the utility would just be X1 plus X2 in some cases, but this is usually how it is in exams. So the professor usually just uses ln in one of the parts. So this is like a really good example. The price of pizza is just P1, price of beer is P2, and Bob's income is M. So like I said in like the previous slides when we were going through it, you need to know how to find a Marshallian demand function. So this is what we're going to be doing now. As seen above, the utility that Bob will get here is 20 ln x1 plus x2. The marginal rate of substitution for good 1 and good 2 is equal to negative mu1 over mu2. So this is just like when you differentiate in respect to x1 in the first case, and then in respect to x2 in the second case. So I didn't like show out more steps for it because this is a pretty basic like differentiation. And also I forgot to mention, you can't really see it in this section. I don't really know why I got cut off, but for like log differentials, the professor usually gives you like what the differential is at the bottom as like a footnote so that you don't have to spend time like calculating it. So yeah. So in this case, it would be minus 20 over x1 over 1, which is just minus 20 over x1. So I was talking about interior and corner solutions before. So here we're going to solve for the interior solution. So this is basically like the marginal rate of substitution is basically when both the curves meet or the slope, which here, as you can see, the slope is negative P1 over P2 or negative 20 over X1. So I just rearranged it so that you can see what X1 would be. So this is it. X1 is equal to 20 times P2 over P1. And so here there's two parts of how you write a Marshallian demand function out. Firstly, we will just go on with the X1 that we derived from rearranging this like the marginal rate of substitution. So here, this is important. This is the way that you're supposed to write it out. Some people have different styles of writing it, but this is what we did like in class. So this is just what I'm gonna show you. So X1, open bracket, P1, comma, P2, comma, M, close bracket is equal to 20 times X2 over X1, which as you can see, I've written over here. So I've just, done the same thing here, but in like with X2 so that I could like demonstrate what it's supposed to look like when you write it out. Here, it's X2, P1, P2, M, and here, this is what it is. It's M minus P1, X1, all over P2. And the way that I solved it is basically when you write down like what the kind of demand function is originally, you know that this is what it's supposed to be like. M is equal to P1 plus X1 plus P2, M is equal to P1 times X1 plus P2 times X2. I did this in the previous workshops. This is just something that you have to remember that like, your income has to equal the price and quantity of one good plus the price and quantity of the other good, or it can be less than that. But in this case, we just equate it. Just give me a sec. Okay. So here we just rearranged it to find what X2 would be. As you can see, it's just this part, which I've written over here. And then, but now we know what X1 is in terms of the marginal rate of substitution formula. So I just substituted that in here. And as you can see, the P1s cancel out and this is what it becomes ultimately. So this looks a little bit messy, but if you when you do it in an exam, all you need to write is this part, 20 P2 over P1, and then this for the X2 part. And now, as I was saying, there's two parts of how you do the demand, the Marshallian demand function. So now we see that M over P2 minus 20 is what you get for X2. Now you have to decide for what kind of range or values is this demand function valid for. So here, this is how we've written it, because if you equate this to 0, so m over p2 minus 20 is equal to 0, and then you solve, kind of not solve, but kind of rearrange, you get m over p2 is bigger than or equal to 20. This is what we want. If the demand function is, if m over p2 is less than 20, you can't use these demand functions that I've written over here, like 20 times p2 over p1 and m over p2 minus 20 doesn't apply for that. So this is us solving the first part, and this is the first part of the Marshallian demand function. And now moving on to the second part, which is when we write m over p2 is less than 20. In that case, I'll start with x2. X2 is just gonna equate to 0, because if we did it kind of here, it would also like equate to 0. So that's all you have to write down. And therefore the demand function for x1 would just be m over p1, because we don't kind of consider x2 anymore. You don't consider any of it. So it's just kind of, it's like there's only one good. So in this case, I'm pretty sure it was, sorry, it was pizza. Yeah, so x1 is pizza. So this is it. This is basically how you solve the first part of the question. So does anyone have any questions on this?
Yeah, I still don't have clear how you got the m over p1.
Okay, so m over p1 is basically, do you understand why it's 0 here?
Yeah, I got that one.
Yeah, so what, like I can't write it out now because the whiteboard function isn't working, but basically, if you look at this equation, m is equal to p1 times x1 plus p2 times x2. If you put x2 as 0 here, no matter what p2 is, it'll cancel out, right? When you're trying to solve, because when you multiply with a 0, it just becomes 0.
Yeah.
So that's why if you rearrange the formula, it'll just be m equals p1 times x1 plus 0. So we've gotten rid of the 0. And then when you rearrange for m equals p1 times x1, if you make x1, like you separate it, you just get x1 equals m over p1. Does that make sense?
Yeah, I don't know why I didn't get it the first time.
Oh, that's okay. I've tried to like write out as much as I can to kind of like make it easy for people, but I guess I just missed this. But yeah, just like feel free to ask any questions, like clarifications, but this is basically it.
Yeah, now that you explained it, it's pretty clear and pretty easy to see.
Okay, that's good. So this is the first part of the question. Question B was actually quite long, but it's still worth the same amount of marks, which doesn't make sense to me. Sometimes who's your professor this year?
Professor O.
Okay, so he's not actually the professor I had last year then, but I feel like his exams might be like the same anyway. Usually it's just 2 questions and it's either 50% and 50%, or it's like 60-40. So, yeah, so this is basically the first part. That's all you need to do to solve a demand function, and just show it to, like, you know, just write it out. The second part of the question is when they give you the income. So we know that m here is 200, and they give you a price of one good. So in this case, they've given us the price of pizza, which is p1, is equal to 10. And here they ask us to like draw out the demand curve for beer, which is x2. So like before, I just wrote out what the like function is, the basic function, because I feel like it just helps me like remember. I don't know why, but so yeah, here we see that it's 10 times x1 plus p2 times x2 is equal to 200. Now, when we go back and see, we see that there's 2 parts of it. So here, m over p2 is bigger than or equal to 20. So that's what we are going to be working with here. Because 200, we just go with 200 over p2, which is m over p2, is bigger than or equal to 20. So in this case, P2 is bigger than or equal to 10. It's important to write it out like this so that you know what to like label in your, when you draw out the graph. And here it's the same, the second part of the equation, 200 over P2 is less than 20. So P2 is less than 10. Now here, I don't know if you want me to like go back so that you can see it, but basically the function for x1 is 20 times p2 over p1. So here it's 20 times p1, which is 20 times 10, which is 200, which is why I've written it like this here, over p2. We don't know what p2 is, minus 20. So here we're only solving the stuff for x2. So we don't do this, oh, sorry, I think I said that wrong. So I'm just gonna go over that again. This is if P2 is bigger than or equal to 10, the first part, which is equal to M over P2 minus 20. M over here is 200. Oh, sorry, here. M over here is 200 over P2, which we don't know, minus 20. That's basically it. And for the second part, which is when M over P2 is less than 20, or in this case, P2 is less than 10, it's 0. Is this clear for everyone? Because I feel like I said something wrong in the middle. Okay. But this is basically it. It's just kind of like putting in the numbers to the equations that we created in the last question. So in order to create a demand curve for beer, this is how we're going to do it. The two parts are important, like the two Marshallian demand function parts are important for the graph. So as you can see, when P2 is less than 10, these labels are wrong, so I'm going to change those. But when P2 is less than 10, which is over here, it's, okay, just give me a second. I'm just gonna stop recording for a sec because I think I just confused myself. Okay, yeah, so the labels for this are wrong. So I'm just gonna tell you what it's supposed to be. So this is X2, it's fine, but this is supposed to be P2 because this is where the price is. So here you can see that X2 would be equal to 0 in this case. And then the demand curve is just downward sloping, which is when you solve for this. So that's all you have to do in this question. When I upload the stuff or send it to you guys, like the presentation, I'll fix it. I don't know why I did that, but this is basically it. So this question, as I said, is quite long. So we've done two parts now. And the third part is where they give us P1 is equal to 10, P2 is equal to 5, and they ask us for the angle curve for beer and pizza. I don't know, like I didn't go through the angle curve with you, but like I'm pretty sure you did it in class. So in order to do that, again, it's really important that you get the first question right, which is the Marshallian demand function, because everything kind of depends on that. Everything you do is just building up on that. So here, M over P2 bigger than or equal to 20. Again, we don't know what M is, but we know what P2 is. So M has to be bigger than or equal to 100 in the first case. So again, when we substitute, you do 20 times P2 over P1, which is equal to 20 times 5 over 10, which is 10. And then X2 is M over P2 minus 20, which is M over 5 minus 20. And then here, again, it's for if M is less than 100. So X1 is just equal to M over 10 because P1 is 10, and X2 is equal to 0. So this is how you have to draw it in this case. In this case, the labels are right. I don't know why they were wrong for the last one. But here on the left curve is the angle curve for pizza, so X1 in this case. So the x-axis has to be labeled X1 and the y-axis has to be labeled M because we're talking about the like in terms of income. Now here, as you can see, M is less than 100. which is why here the demand, the curve will get like kinked at 100, because that's when the function kind of like starts to change. So when it's less than 100, this is what the function is. It's m over 10. So this is why it's like a straight line. And then when it's more than 100, it's just equal to 10. So it's constant. So I should have labeled this here as well. Here it's supposed to just be 10. Yeah, x1 should just be 10. So there should be a 10 here. I'll write it when I upload it. But this is pretty straightforward. If you're confused about how you're supposed to get this part of the curve, what I would recommend is to put in values. So here when m is less than 100, I would just put 90 over 10, like 10, you know, like just pick values for the income, which are actually less than 100. And then you can kind of just put the points and connect them. That's what helps me, but I didn't do that here just to like, you know, not take more time. But that's the angle curve for pizza. And this is the angle curve for beer. This one is pretty easy as well, because as we know, when the income is less than 100, which is over here, that's where it gets kinked. We know that x2 is just 0. So it's just 0 over here. We don't have to do anything else. But here, it is m over 5 minus 20. So like I said, for the pizza angle curve, you can do the same here, where you just put in values of m where it's 100, and more than 100 to kind of just connect the dots then. Does anyone have any questions about this? Nope. Okay, yeah, it's pretty straightforward, but this is what my midterm was like last year. It was pretty similar. Now, the fourth question actually has a lot of parts, so I'm going to go back so I can talk you guys through it. So, suppose P1 is equal to 10, P2 is equal to 5, and M, the income, is equal to 200. Here, they ask us to find Bob's best affordable bundle. So that's the first part of the fourth part of question B. Then after that, they ask us if there's a 60% sales tax on beer, what will Bob's new best affordable bundle look like? And then there's a third question, how much tax does Bob pay? So the way that I've done it is I've answered one question and then stopped and then done like the others. So I'll just talk you guys through it like that. So here, his Bob's best affordable bundle when P1 is equal to 10, P2 is equal to 5, and M is equal to 200. So here, I've just calculated M over P2, which is equal to 40, and 40 is bigger than 20. So we just do the first, like kind of the first parts of the Marshallian demand function. Like we just use the first part. So here I just substituted all the things because we have all the values that we need. So x1 is equal to 10 and x2 is equal to 20. What I should have done is also write out kind of Bob's best affordable bundle is equal to open bracket 10 comma 20 close bracket. That's what you should do, but even if you don't, it's kind of okay because you can see what the like values are. Then, so that's the first part. The second part tells us that there's a 60% sales tax on beer. So now what is the best affordable bundle? In this case, the value that changes is P2 because now the price of beer has changed. It's become more expensive. So just in order to calculate P2, like the new P2, it's 5 times 1.6 because it's a 60% sales tax. So that's just how you calculate it, which is equal to 8. So now P2 is 8. So again, we just substitute in the values. Everything is the same except instead of 5 here, now we are just substituting in 8. So here you get that x1 is equal to 16 and x2 is equal to 5. That's his new affordable bundle, his new best affordable bundle. The third part of this question talks about how much tax Bob had to pay. So in order to calculate that, this is the formula that we use. The first part of the formula, which is 5 in this case, is what x2 would become after tax, which here we see is 5. Then we look at the pre-tax price, so the original P2, which is also 5 in this case, and then you do the tax rate. you just do 0.6. You don't have to put 1.6 because they're just asking for the tax rate, not to calculate an increase in the, like, you know, through tax, which here is equal to 15. So this is how much tax Bob paid. This is all of the fourth part of question B. Does anyone have any questions? Okay, I think we're good. Finally, this is the last part of the question. This is basically the last question in the exam. I'm going to go back to it so that you can see that, and then I'll show you my notes. So T is equal to the amount of tax that Bob pays in question 4. So we calculated that it would be 15. Suppose the government decides to abolish the sales tax on beer and replace it with a lump sum income tax of $T. So P1, P2, and M remain the same as like these ones, so 10, 5, and 200. And here they're asking us to calculate what is Bob's best affordable bundle. Does he prefer it with the sales tax in question 4 or with the lump sum tax in question 5? So first, what we have to do for this question is calculate what it would be like, what his bundle would be like if there's a lump sum instead of a tax. So let's do that now. So here I just wrote some notes. So the income tax T is equal to 15. So what changes here in order to calculate his best affordable bundle is the income, because now if he has to pay income tax, his overall income will get reduced. So here to calculate M, I just wrote M1, which is for like the new income. You would do 200 minus 15, which is equal to 185. So that's all that we need to know. Now using this, again, I've written out, you know, to make sure that M over P2 is greater than 20. It usually is, but just to make sure, always I just write it out. So 185 over 5, because 5 is P2 from question 4. We're not looking at 8 anymore. We're not considering this because this doesn't exist anymore. So this is all you do, and then you calculate X1 and X2. So it's 10 and 17. That's his new affordable bundle when there's a lump sum income tax instead of a sales tax. So in order to decide which like bundle Bob prefers, first you would calculate the utility with sales tax and then the utility with the lump sum income tax. So we haven't even used this equation yet, which is the utility equation, the utility function, sorry. So if you go all the way back, it says his utility function is u x1, x2, 20 ln x1 plus x2. So this is what we are using now. So you just substitute in the values. With the sales tax, it's 20 times ln 16 plus 5. And you're allowed a regular calculator in the exam. So this is what you get, 60.45. And then with the utility with income tax is 20 times ln 10, which you got from here, plus 17, which is also from here. And his utility here is 63.05. So now we know that Bob prefers the lump sum income tax because his utility increases. So 63.05 is more than 60.05, and we just know that he gains more utility if there's an income tax instead of the sales tax on beer, and that's why he prefers this bundle. So that was basically it. That's a whole midterm, because it shouldn't, like, our classes used to be an hour and a half long, and I think it's the same for you. That's how long it should take you, but usually it's like, it doesn't even take you that long if you've done the past midterms. And yeah, this is what it's like. Does anyone have any questions about like anything that I've done, like any of the questions I've done? I know that like it's not that complicated, but if anyone just has like anything they want to get like clarified or anything like that. Okay, I think we're good then. I'm gonna stop sharing and I am going to stop the recording.